Hello YouTube viewers, welcome to my show Computer Wednesday. In today's episode we're going to take a closer look at Power over Ethernet or PoE. So let's dive right into it. Now first thing you have to understand why the heck there is a need for this PoE. You have to understand there are many loads, as in the electrical loads, that are not very demanding. Like not everything requires as much power as a hair dryer. Basically like a VoIP, voice over internet protocol phones, they are very power efficient. When you are talking about routers, they barely consume 5 to 10 watts or 20 at maximum. Security cameras, the old one used to consume a lot, but modern ones don't consume a lot. So in this sort of scenario, we have a system where you have a lot of equipments, but they don't consume a lot of power. However, you still have to deal with the aspect that it needs power plus data. So whatever their data line may be, their phone line, their Ethernet cable, whatever that may be, they need that plus they need power. So they will generally have independent power system, something like a basically AC wall adapter. Consequence of that is very like a lot of hassle you have to go through. So basically, let's say you want to mount a security camera somewhere. Okay, you mounted it and you routed the data cable to from your server room to basically where your security camera is. Awesome, everything is fine. However, how you gonna do the basically electricity over there? Because 110 volt or 220 volt in case of places that use 200 volts, it's not easy to just have a cable going there and basically terminating it with a plug, then putting a adapter there and then doing this. Very prone to mishaps and accidents, because if you do electrical wiring before the building is built, you can do it with basically a lot of caution and safety records. But once you do after on, like add-ons, they are not very safe. For this reason, we want to centralize this. So basically we want to let go of power plus data. We just want one thing and we want to reduce the hassle and centralize it. Now the question becomes, why the heck you want to centralize? Basically everything is happening in that central location. So you can have hundreds of security camera, but you're not gonna have hundreds of control room. You're gonna barely have 1 or 2 control room at max. So we centralize anyway. So centralizing, like let's say you have a VoIP phone. Not every phone you have is gonna be connected to internet independently. All of them would be connected to a network. Then that network would be connected to the gateway. So in those sort of scenario, you are centralizing one way or the another anyway. So centralizing the power also helps you a lot. So this is the need. You have a lot of equipment that consumes very little power. I'm talking 10-15 watts or something like that, but you have a lot of them. And running a basically AC live wire to their location could be very like tangibly dangerous, and a lot of hassle is involved into that. So we want to get rid of this power adapters. So that is why we have a need for it. So solution is, some smart people came up with the idea, let's use Ethernet cable itself to carry the power. Now this is what we call PoE. This is what I'm talking about. However, you have to understand, because PoE is standardized, we can make a scenario where you can have, let's say your security camera is from Sony and your computer is from Samsung and your switch is from Cisco. It will work because it's standardized. So in standardized term, there are 2 core terms you have to understand. One, you have power sourcing equipment, PSE. Basically this is the puppy that adds power to the network. Basically this is the one providing the power. This is your wall adapter, quote unquote. And then you have powered devices, basically the receiver, security camera, your VoIP, things of that nature. So these are the 2 core components you have to understand. Now there are many standards, and their naming convention will drive you crazy. So I'm gonna try to simplify it. Now you can see this graph, and I will link down the Wikipedia article, but in simplest term, if all I have to do is simplify it to you, you have to understand it this way. There are 802.3, that is the standard number, and on top of that you will always hear extra things added to it, like PoE, that's the standard number 1. Then there is PoE plus, which is extra power. Then there is 4PoE, I have no idea what they named it. Then there is type 4. So you can understand this is very complicated. The way the computers can handle this without frying your security camera and your routers and all that is because there is a handshake involved. So do understand, you can do this passively, but every goods provider, basically power provider, power sourcing equipment and good power devices, they generally do a handshake. So they can make sure the power provided matches the power needed. So they cannot have a scenario where it roasts your equipment. And the cable used is basically Cat 3, Cat 4, Cat 5 and Cat 6. You don't have to have Cat 6. You can easily rely on Cat 3 to Cat 5. They use exactly the same cable, exactly the same connector. You don't have to change your wiring basically. And that handshake also makes sure that, let's say you have a scenario where the equipment requires basically lower voltage than what you are providing, the handshake will make sure that it does not roast your equipment. Now, to give you a rough context of these things, basically you have the first standard, the PoE, the original standard. It was barely capable of giving 12 watts, 10 watts maximum. Like 10 was like every equipment was designed to make sure it works under 10 watts. So there, let's say a phone, when it's ringing, it consumes a lot of power because it's running a loudspeaker. So in that time, it will consume upwards of 12 to 15 watts, but generally they made sure that it works under 10. You never want to be like, maxing out to 100%. So let's say PoE, just think of it as a 10 watt system. Then came PoE plus, second standard on top of that. Generally, sometimes it's referred at 80 standard, from 802.380. Don't think too much about it. Basically PoE. Then came the second edition, that PoE plus, that can deliver upwards of 25 watts of power. So people can now use equipment that can consume 20 watts. Now this allows us to take care of access point routers basically. Then the 4 PPoE, I have no idea who is naming these things. Basically the BT standard, type 3 standard. Now these can go up to 50 watt. Now you're talking a lot of power. Now that power is so much that you can do a security camera, and that security camera what we call PTZ camera. Basically you can check my last episode about that, Pan-Tilt camera. So basically not only you're gonna run a security camera, you have enough power that you can move the security camera around, zoom in physically, because those things also consume power. So you can now run an active camera using this much power. Then the latest standard right now, type 4 standard, that goes up to 70 watt, and at maximum draw you can reach upwards of 100 watt. To give you a context, now you can run laptops of this. So these are the standard. You don't have to think too much about it, because there is a handshake to make sure that you can't do anything stupid. And there are basically, you can use your normal Cat 5. That's it. There is just PoE, PoE plus, then random type 3, then type 4. Type 4 is the most powerful one. So this is how we solve the problem. Now then, okay, how we are implementing it. Now in implementation, you have to understand, let's say you are like me. I have a WiMAX adapter at my rooftop, which is just receiving the signal from my internet service provider. But again, it's at my rooftop and it is on top of a very tall pole. So I don't want to run two cables to it now, but I have to run Ethernet from it to my router. So Ethernet is already there. So what the company service provider did is they bought something known as PoE. So this receiver is basically PoE. So all I have to do is, like, wherever I'm connecting my basically router, my router is right here. That router itself has a basically electrical appliances. I add what we call PoE injector. So basically, if I am taking care of one thing, we generally call it local. So all you are doing is basically you are sending that Ethernet wire. Only one wire is going to my basically receiver, and that's it. Nothing else. On the ground end, I have one Ethernet and adapter setting where I can plug in my basically normal wall watt. So that's localized implementation. So let's say you are only dealing with things that like you need only one, then you will do localization. But let's say you are talking about PoE, basically VoIP, you need to have centralized system, because you're not going to have one phone, you're going to have 3, 4, 5 or however many. You need to have power over Ethernet, and you have to have it centralized. Now centralized also have other benefits. Let's say you centralize it, this also gives you the idea that you can have UPS, as in power backup for entire network, and that can be controlled from one place. That makes it very resilient to power outages and somebody accidentally slugging the cable or things of that nature. And switching off cannot happen because it's now would be in server. So people generally centralize things. Now certain things you have to centralize, other things we generally improvise smart switches. Basically any office that you go to generally will have PoE wireless access point. So they will have a router room. Basically the internet comes into that room. There will be a big expensive firewall integrated router, and then after that router the connection will go to a switch. Now that switch would be PoE enabled switch. That switch will feed power and data to a access point, and that access point will be placed everywhere on the ceiling. Generally 10 feet apart, or sometimes 20 feet apart, depending on the capacity of the access point and how many clients are there. So this is how we implement it. You can have one-on-one. So basically, let's say all you are dealing with is like, hey, I have one let's say Wi-Fi router that I have to put on top or on second floor. Many of you have multi-floor homes. So in those sort of scenario, you can do this. Now you might be like, okay, my router is not PoE enabled. You don't have to worry about it. There is PoE injector you can buy, and from that PoE injector, it will be simple one plug. You plug in your DC adapter and you plug in your data, then it's PoE, the cable becomes PoE enabled, and from the other end where you are receiving, you can do the same. Basically you can extract the power and then connect in the data port. It won't fry anything, and that DC output you can connect to your router. So that way you can make anything that is not PoE enabled enable PoE. Like you can simplify the cable management. Now is it good enough use? That's up to you. So this is how we implement it. Now every office uses it. So is there a future into this? Well, yes, because the latest standard can support upwards of 70 watt. That's a lot of power in terms of LED lighting. This whole room that I am in here, right, it's a big room. It's lit by 100 watt LED tube lights. Now 100 watt is a bit too much for this room. Now the reason why it's not overexposing to you is because I have lower ISO, but for a human eye it's more than bright enough. It's more than bright enough. So let's say I have two 50-50 watts. That is more than enough for normal PoE systems. I can easily well lit this room from one cable and control it also. So you can have a scenario where you have large smart building. When people leave the room, the computer can detect it. Okay, like this computer is not being used and the client has been shut down. It can shut down the light also. So you have one place of control. LED lighting is also making it, so you can get a lot of fixtures that directly support normal dumb PoE, basically where you can only turn it on or off using Ethernet, and there are smart PoE where you can, like, okay, at 6 a.m. so turn the light in, bit bluish, not bluish, I'm saying bit yellowish, so people can, like, know that it's time to go home, and this sort of thing can be done. On top of that, point of sale, basically the computer you see at McDonald's or Domino's or Pizza Hut, basically is just doing one thing, like basically taking your order, swiping your card, and that's it. The whole computer can be made to run on power over Ethernet. I have provided links down below. You can see about this system. This is specifically targeted for medical application where people are doing a lot of report searching and all that. It can be powered over directly one cable. That's it. No communication, no internet system. And it provides USB power, so your keyboard and mouse will work from this, and you will have only one cable. This is from AMD. The system, basically, it's a AIO, all-in-one system. So the AMD system is like quad core, have 16 GB of RAM, and it can do mild work. Like, don't expect it to like do 4K video editing, but it's made for point of sale, so it is more than sufficient for what it has to do. And all you have to do is take care of one cable, and this whole system is now only 30 watts of power consumption. And this is another example of having a 30 watt LED bulb in a server room. So this sort of thing is becoming much and much more prominent nowadays because of PoE's higher capacity. Now, can we expect another PoE standard that exceeds that 100 watt limit? Unlikely. The reason for that is every cable has inherent limitation. So you can increase the voltage, but you can't increase it voltage without making it unsafe. If you increase the voltage, the cable becomes unsafe because the insulation is rated for a certain voltage. I think they have maxed out, and they can make cable thicker, but it will make it more expensive and you have to buy a new cable. So right now they are throwing upwards of 1 amp per cable, like that 8 cable inside. You can send upwards of 1 amp safely. You can send upwards of 50 to 60 volt safely. Can they increase that? No, I don't think so. Like they may come up with new standard, new way of sending more power, but as of now, as I'm talking to you, the 100 watt limit is like the maximum. They cannot make it more powerful unless they have to change it through, let's say they physically have to redesign the connector. So 100 volt is a lot of basically potential difference. So electricity can jump. Electricity can directly damage the plastic insulation. That is why all the home cable that you see that is only rated for 100 volt use, but insulation will still say 1000 volted rated. So for that reason, I don't think we're gonna have a future where we're gonna have like 10 kilowatts sent over Ethernet. It's pointless. But it's more than enough because our equipment is becoming more and more efficient. You can easily see a scenario where we are using your point of sale, your LED lighting can be taken care of by PoE. So this is a very good development that's happening right now, and I'm thinking that we're gonna see a lot more of PoE in the future. And I have provided a lot of video down below that you can see to learn more about this. So this was my presentation on PoE. I hope you liked it or learned from it. In that case, please leave a like. If you didn't like it, don't worry about it. You can press dislike. I would urge you to press it twice to show me your extra disappointment. Now, you can also leave a comment because I reply to all of them. And if you really want to help me out, please click the ad shown in this video. That will directly help me. And subscribe, press the bell icon if you're free. And as always, thanks for watching.